Hi, my name's Professor Will. So I'm going to talk to you today for about 6 or 7 minutes about antennas and electromagnetics and how that is related to your undergraduate degree. So first of all, I'm in what we call an anechoic chamber. So this is a specialist piece of research facility for measuring antennas. I'll come on to this a little bit later. Okay, so when do we use antennas? Well, anytime we want to convert a signal from a voltage into an electromagnetic wave, so anytime we want to send anything wirelessly, we're going to need antennas of some sort. So what applications? Well, there's obviously mobile phones, there's 5G and how that's going to change our lives. Then you've got base stations, you've got modern cars that typically have about 25 different types of antennas these days, from anything from keyless entry to parking sensors. Obviously, driverless cars are going to need antennas for the radar. Then you've got planes, you've got medical devices implanted inside a human body. You've got space communications. Anything you can think of that is going to use electromagnetics. Also things like RFID tags and the Internet of Things. So everything is going to be wireless and everything is going to use some sort of antennas or electromagnetics. So in your first couple of years, you will do some of the theory and some of the basic concepts. And you'll start with circuits, and then we can extend how circuits can be transferred and be analogous to electromagnetic waves. So I teach a module in Part D in your 4th year called Antennas. So this is a 1-week block talk module. So what you'll do in this module is you'll learn some of the theory and the applications and some of the practical issues in terms of how you can design antennas and how they work and how you can make them smaller and get higher bandwidth and things like that. So what our students will do is they will spend most of the first 4 or 5 days learning the theory. Then we will do some simulations. So I've got my laptop here if you can see it. So then we will do some simulations of a patch antenna. And then students will actually go into the lab and actually make something. So then the students will actually try and make this patch antenna. So it's a fairly simple device. It's a piece of metal, a connector we can put to a cable, and a patch antenna that students can make themselves out of copper tape. So this is something that's quite simple and students can do in a day. But it's amazing, the learning process, that it's difficult to understand the physics just from the electromagnetic equations. But once you can actually do a simulation and see the electromagnetic fields and the currents, and then you can actually make something and measure it, and you can put your hand near it and see how it changes things, it kind of brings the whole learning process together. So it's a really important thing. So you can think of antennas, and I guess the key thing about when you do a measurement, it's never exactly the same as when you simulated it. So then you have a fun idea, the fun process of trying to work out why is your measurement not exactly the same as your simulation, and how you can change things. So we talked about before that an antenna is great for any time you want to send anything wirelessly. Antennas great for anything you want to send wirelessly. So you can think of it a bit like an analogy between a light bulb, a torch, and a laser pointer. So it's fairly intuitive that a light bulb is going to send the light equally in all directions. The torch is going to be relatively focused, and in the extreme case, you have something like a laser pointer, which is sending all its power in one direction. So antennas, you can think of exactly the same concept. We don't want just to see how much power they transmit or receive, but we want to see how much is sent in each direction. So we have this specialist piece of research equipment. So all our academics are research active, which means we're all kind of involved in research. And we basically, 2 or 3 years ago, we got this anechoic chamber, which cost us kind of about £400,000. So this is a very specialist piece of room for measuring antennas. So what we can do is we can have one antenna that we know the properties of at this end, and then the antenna that we want to test at the far end. And then this is a robot, so we can move that antenna around in both axes. So we can move it around in both axes, and that's like understanding exactly how the antenna is working in 3 dimensions in the entire sphere. So that is a great way of understanding how the antennas work, and we can combine our specialist research facilities for our undergraduate teaching. So as long as you know the distance between the antennas and how much power you transmit, you can measure how much power you receive, and if you know the distance between them and the frequency, you can do some simple maths to work out how well your antenna is functioning in each direction. So you can see that there's lots of these pyramids or kind of spiky triangles on the outside of this wall. So basically this is a metal box and it's lined with what we call radar absorbing material. So the idea is when the electromagnetic wave bounces, basically the idea is you get no reflections of the electromagnetic waves when it hits the metal boundary of a box. So any electromagnetic wave is going to hit the walls, it's going to get bounced up inside and down in between the radar absorbing material, and then it's going to be absorbed and you're not going to get any reflections, and therefore you're going to get a very accurate, very reliable measurement. So yeah, you can think of how many products and devices are going to require wireless communication within the next 10, 20, 50 years, and how few people understand antennas or electromagnetics, and therefore job prospects are pretty good in terms of if you have that knowledge and expertise, it's pretty good. Obviously in your final year, whether it's BEng or MEng, you will do an individual project. So like most academics, I set my individual projects quite closely related to my research. So what have my previous students worked on? Also, my current students are working on a 5G antenna arrays. One of my students is working on a wearable antenna. One of my students is working on a satellite antenna arrays, and other people are kind of testing measurements and developing new systems. So to give you some examples of what my previous students have done, so this is an antenna that we were able to 3D print, so we could work with the manufacturing group and kind of 3D print this antenna using conducting ink. And then this is a small antenna that we were able to make just using a desktop printer and sort of specialist conducting ink, but it's quite fun to be able to see it in real time. Furthermore, we have a project a couple of years ago about a wearable antenna. So this uses an embroidered thread. So that is great to make it flexible and comfortable for the user. So all my projects kind of involve going away and reading some academic technical papers, which is really difficult at first, but the more you do, the easier it gets. And then going away and doing some calculations, doing some simulations, and then making it. And then potentially we'd use this anechoic chamber again when we do our measurements. I've also got a couple of project students in past years and this year who make these kind of 3D printed lenses. So you can see that this one is just a solid one material, and this has got lots of different densities. So the idea of this, so I'm part of a big research project called Symeta, sponsored by EPSERC, and our goal is to try and design new types of antennas and RF devices using 3D printing. So actually my project students work alongside my researchers and my PhD students, and you can make things like these lenses. So the idea of these lenses is you can put it in front of an antenna and it makes it more directive, which means you can communicate more information in a certain direction. So that's especially important for 5G or satellite communications, for example. So that's just a fun thing of how what you can do at an undergraduate level can lead on to your project, and then you can be working alongside PhD students and researchers. And basically I expect my MEng students to be doing something brand new that hasn't been done before, and the really good students are actually able to publish a conference paper. Okay, so I think that was all I was going to talk about. So it was 9 minutes. Sorry, I slightly underestimated. But hopefully that was interesting to you, and you can see how we can combine our facilities and expertise to provide you with an excellent education in terms of antennas. Okay, thank you very much. Take care. Bye.